Dear students, you are welcome in the Education Department at SHAHD Association. Our lesson today is Circuit Connections. Make sure to subscribe to our channel for more lessons, and don't forget to activate the bell to stay notified. In this session, we have three objectives. First, we will calculate the electric current in the series and the parallel connection. We will calculate the voltage in the series and the parallel connection. And finally, we will connect an ammeter and voltmeter to a circuit. In the Explore section, we saw how Sami has chosen incorrect appliance for his circuit. That caused lamp either burn or dim. Now we will see how can he measure the voltage and the current to choose the correct appliance. But first, let's start by defining current. Current is the rate at which charges move. The electric current has a definite direction. By convention, the electric current comes out of the positive pole of the dry cell and enters through its negative pole. What is the unit of current? The unit of electric current in SI is ampere. Milliampere is also used in measuring the electric current. The conversion from ampere to milliampere is that every 1 ampere is 1000 milliampere. For example, 100 milliampere, if we want to convert it into ampere, we have to divide it by 1000. So 100 divided by 1000 equal to 0.1 ampere. Let's take another example. 5 amperes, how many milliamperes? So from amperes to milliamperes, we have to multiply by 1000. So 5 times 1000, it gives 5000 milliampere. In electric circuits, we have two types of connection. The first one is called the series connection. Here the appliances are connected one after another. The other type is called the parallel connection. In this type of connection, appliances are connected side by side. We will start by the series connection. As we said, in the series connection, components are connected one after another, as you can see in the two pictures. The current is the same in all the lamps, and this is defined by the law of uniqueness of current in the series connection. Also, the voltage across them is added up, and this is also defined by the law of addition of voltage in the series connection. In the series connection, we have two laws. The first law is called the law of addition of voltages. Here, we add all the voltages. So UPN, which is the voltage across the dry cell, is equal to the voltage across the lamp 1 plus the voltage across the lamp 2, and so on. The other law is called the law of uniqueness of current. Here, the main current, which is delivering by the battery, is equal to the current that's passing through the lamp 1, and it's equal to the current which is passing through the lamp 2. So I is equal to I1 plus I2. Let's do the following example. We are given this circuit. The first question: name the components of this circuit. In this circuit, we have a dry cell, and we also have two lamps. The second question: show the direction of the current. By convention, current goes out from the positive terminal of the dry cell and enters to the negative terminal of the dry cell. The third question: calculate the voltage across lamp 1 if we are given the voltage across the dry cell, which is 3 volt, and the voltage across lamp 2 is 2 volt. The two lamps here are connected in series, so we can apply the law of addition of voltages. So we write U is equal to U1 plus U2, where U is the voltage across the dry cell, and U1 is the voltage across lamp 1, and U2 is the voltage across lamp 2. So now we need U1, so we take it into another side, and we write U1, it will be equal to U minus U2. So now we plug in, so 3 minus 2, it gives 1 volt. So the voltage across lamp 1 is 1 volt. The other type of connection, it's called the parallel connection. In this type of connection, components are connected side by side, as you can see in the two pictures. The current is added, and this is defined by the law of addition of current in the parallel connection. Finally, the voltage is the same in all components and is defined by the law of uniqueness of voltage. Now we will tell the laws that are applied in the parallel connection. The first law is called the law of uniqueness of voltage. So the voltage across the dry cell, it is the same as the voltage across the lamp 1, it is the same as the voltage across lamp 2. So we write as U is equal to U1, it's equal to U2. The other law, it's called the law of addition of current. Here, we write the formula as the main current I is equal to I1, which is across lamp 1, plus I2, which is across lamp 2. To make the laws in the parallel connection clear, let's do the following example. In the following circuit, the voltage of the dry cell is 9 volts. Is L1 and L2 connected in parallel or in series? So as we can see, the two lamps are connected side by side, so they are connected in parallel. Now if the main current is 2 amperes, and the current which across lamp 1 is 0.5 amperes, what is the current across lamp 2? So in the parallel connection, we apply the law of addition of current. So we write I is equal to I1 plus I2. Now we need I2, so we take it to the other side, and becomes I2 is equal I minus I1. And we plug in 2 minus 0.5 is 1.5 ampere. Now, what is the voltage across the two lamps? In the parallel connection, we have the law of uniqueness of voltage. Then U1 is equal to U2 is equal to U, which is 9 volts. How can we measure the voltage and the current? By using a device that's called digital multimeter. The digital multimeter is an electronic instrument to be used in electrical measurement. It can have many special functions, but the main function is to measure the voltage and the current. This is the picture of the digital multimeter. Electric current is measured in amperes, using an ammeter that's connected in series in the circuit. That's how we connect an ammeter to our circuit. The positive terminal of the ammeter should be connected to the positive terminal of the dry cell, and the COM, which is the negative terminal of the ammeter, should be connected to the negative pole of the dry cell. What's voltage? The electrical push which the cell gives to the current is called the voltage. It is measured in volts. Voltage can be measured by a device that's called voltmeter. The voltmeter should be connected in parallel with the appliance. The V terminal, which is the positive terminal of the voltmeter, should be connected to the positive terminal of the battery, and the COM, which is the negative terminal, should be connected to the negative terminal of the battery. Let's do a small exercise on how we can convert from amperes to milliamperes and vice versa. The first one, 1 ampere to milliampere. From ampere to milliampere, we have to multiply by 1000. So 1 times 1000 is 1000 milliampere. The second example, 300 milliamperes, how many amperes? So from milliamperes to amperes, we have to divide by 1000. So 300 divided by 1000, it gives 0.3 amperes. The final example, 0.05 amperes, how many milliamperes? So from amperes to milliamperes, we have to multiply by 1000. So 0.005 times 1000, it gives 5 milliampere. Let's do another exercise. In which of the circuits that are represented by figure 1, 2, and 3 is the voltmeter connected badly? In figure 1, the voltmeter is connected in series with the appliance. We know that the voltmeter should be connected in parallel. That's incorrect. In figure 2, the voltmeter is connected in parallel with the appliance. The positive terminal of the voltmeter is connected to the positive terminal of the battery, and the negative one is connected to the negative terminal of the battery. That's correct. In the final figure, the voltmeter is connected in parallel with the appliance, but the negative terminal of the voltmeter is connected to the positive terminal of the battery, and the positive terminal of the voltmeter is connected to the negative terminal of the battery. That's incorrect. So figure 1 and 3, the voltmeter is connected badly. In figure 2, the voltmeter is connected in correct way. Let's do a third exercise. We have the following circuit. The first question. Name the components of the circuit. The components of this circuit are the dry cell, which have a symbol like this. We have two lamps, L1 and L2, having a symbol like this. We also have a connecting wire and a closed switch, and we have two motors. Question 2. Is this circuit closed or open? Justify your answer. The circuit is closed because the switch is closed. Now show the direction of the electric current in this circuit. We know that the electric current is directed from the positive terminal of the battery to the negative terminal. So we put an arrow coming outside from the positive terminal and returning to the battery to the negative side.
Thanks for watching. If you like this lesson, make sure to subscribe to our channel for more. And don't forget to click the bell to get all updates.